Very good morning to all. I am Dr.Senthilkumar, Associate Professor, Department of Mechanical Engineering, SNS College of Technology. So, as I said, the basic concepts I will explain through the videos. This is the first video which you have not seen in the class. We have directly gone into the numericals. Let me see the basic concepts of radiation. So, what does mean by radiation? As I said in the class also, it is an energy transfer across a system boundary due to temperature difference by the mechanism of photon emission or electromagnetic wave emission. We all know what is meant by boundary. It is the edge or region where we focusing for analysis. So it is due to the photon emission, no intermediate matter for heat transfer. So there will not be any intermediate matter for photon transfer. So for heat transfer there will not be any intermediate matter, that is the radiation. That electromagnetic phenomenon is always described in terms of electromagnetic wavelength lambda. So this electromagnetic wavelength lambda is the important parameter for understanding the concept of this radiation. Thermal radiation, which is varying from 0.1 to 100 micrometer. So as we discussed the previous concepts like efficiency and COP. Efficiency, it is 1 to 100%, COP 1 to 10. This electromagnetic wave which is having the range of 0.1 to 100 micrometer. Now let me see in a diagram how it is varying, what are its names when it is having different forms from 0.1 to 100 micrometer. Here in this diagram representation you can see 10 power minus 6 to 10 power plus 6 micrometer wavelength. So in that the concept which explains the gamma rays we would have studied in our physics also, that indicates that minus 6 to minus 4 is a gamma ray. Excuse me. And minus 4 to 10 power minus 4 to 10 power minus 2 lambda, which is nothing but X-ray, where we are taking our bones and all other human body in X-ray, where we get this kind of gamma rays. 10 power minus 2 to 10 power plus 2 is a visible light, where we are seeing lights nearby our place, or radiation we can able to see through our eyes. For example, sun radiation which is coming as a biases on the road, sometimes when we are traveling we are able to see, that falls under between minus 2 to plus 2 lambda, 10 power minus 2 to 10 power 2, and some of the regions like minus 10 power minus 2 to 10 power minus 1 region, that we are not able to see, only we are seeing while traveling on the road. That may be that concept. Okay. So visible light which is 0.4 to 0.7, that is the visible light, clearly visible light. So that we are experiencing in many of the places, the light which is coming and reaching us. And the region for thermal radiation is 10 power minus 1 to 10 power 2. So in this region only, that is the region for thermal radiation. So in this region only the thermal radiation taking place, which gives the concept of radiation analysis and radiation theory. And microwaves, we would have studied about the microwave ovens and all other concepts for cooking and all other purpose, which is the having the lambda value and the wavelength, thermal radiation wavelength value of 10 power 2 to 10 power 6 micrometer. So this is called as the microwaves. So this concept may be asked in gate question also. Some of the gate question I have seen that what is the visible light wavelength value or range. So there you should give 0.4 to 0.7. There may confuse you. They will give you giving 10 power minus 6 or 10 power 2 to 10 power 6, some value, different value they will give in option. They will try to confuse you. You have to clearly understand the concept where the light is visible light, which is 10 power 4 to 10 power 7, 10 power minus 1 to 10 power 2. In between that, 0.4 to 0.7 value is the visible light that you should understand and elaborate, understand and answer in the gate question or wherever the objective question appears. So hope you understood what is the wavelength and what are its value of range of the thermal radiation and its ranges on the different rays, gamma rays, X-rays and microwaves, and region for thermal radiation and visible light. So with this, I stop this lecture. Thanks for the opportunity. Thank you.